So welcome to today's lesson. And of course, I'm going to be taking you in engineering mathematics. And I gave the course outline. I gave you yesterday the course outline. So let's see what I've prepared for you. I hope you are all getting my voice. Yeah. So we're going to start with differential equations, and then on these differential equations, we'll start with the definition. First, we need to know what a differential equation is before you start solving questions. So today I'm just going to do an introduction, and then after introducing, we'll also solve simple questions. Yeah, how to come up with differential equations. Then after that, that's when we'll now go into details. Yeah, then even tomorrow we may have a lesson. Yeah, preferably mathematics again, or maybe dynamics. So what is a differential equation? So any equation that involves differential coefficients is called a differential equation. So according to this definition here, saying a differential equation is an equation which involves differential coefficients. So what are differential coefficients? I'm sure um, most of us we know. Okay, let me just check. All right. So I'm sure most of us, let me just get a pen so that I should be writing something. Okay. I'm sure most of us know about dy dx. You all know what dy dx is. So that dy dx is what is called the differential coefficient. I don't know why it's refusing to bring up a pen, but I want it to be solving. Anyway, I'll work on it. My laptop is still having some issues, but I'll work on it. So today I may not be writing, but I've prepared everything properly. I'll just be pointing. So let's look at some examples of differential equations. So like I said, any equation that consists of differential coefficients is called a differential equation. When we look at this equation here, the first equation, we have dy dx there. So we have dy dx there with the degree of 1 and the order of 1 as well. So meaning, anyway, I'm going to explain everything. But here, since we have dy dx in this equation, we're calling it a differential equation. So this one this one is also a differential equation with order, which is 2, and then the degree is 1. And then this one is also a differential equation, but this one, for you to determine what the order and the degree is, you first need to simplify it. I mean, the order here, you can get it, it's 2, and then the degree is 1. Okay, I'm going to explain what the order is and what the degree is. So here we also have dy dx. These are partial differential equations because we have partial differential coefficients there. Even this one is just the same. So that's what a differential equation is. So sorry for the inconvenience today. I never knew to say PowerPoint. My PowerPoint is going to refuse to write. So when we meet in our next lesson, I'll make sure that it's writing before I even start teaching. Okay. So there are 2 types of differential equations. And then these types, we have ordinary differential equations and partial differential equations. And then when we talk about ordinary differential equations, was simply talking about differential equations with only one or a single independent variable. What do you mean by an independent variable? When you look at when you look at the first equation there, this one can be termed to be a single. This one has a single independent variable, which is x, because we differentiated this with respect to x, with only x, with respect to only x, not any other variable. But when you look at this one here, this is a partial differential equation. Why? Because we have three variables, meaning it involves more than one independent variable. So and I mean, hence it's called a partial differential equation. So the differential equation which only consists, or which only involves a single independent variable, is called an ordinary differential equation. And then the one which consists more than one independent variable is called a partial differential equation. So let's move on and see what we need to know next. So let's now talk about the order and the degree of a differential equation. So the order of a differential equation is simply, okay, the order of a differential equation is the order of the highest differential coefficient present in the equation. So what does that mean? Look at these equations here. So when you look at these equations, you check that we have the 2q dt2, and you also have the qt, I mean the q dt. So now when you talk about the order, you simply get the 2q and the, I mean, you simply get the 2q dt2. So meaning the order of this differential equation, the first one here is 2. Why? Because the highest differential, I mean, the highest order of this differential equation is 2. We have 2, we have 1, and we have 0. So here the highest is 2. That's the biggest number that we have on the QDT. Yeah, we have 2. And then when we talk about the degree, we are simply talking about the power of the highest differential coefficient. I mean, of the highest power of a differential coefficient. I don't know if you've gotten my English there. Yeah. So when you look at the second one here, the second one has d2, d2y dx2, and it also has dy dx there. So here the order is also 2. Let us also look at this one. Even this one, the order is 2, but they have different degrees. Okay, do we have a question?
Can you please repeat what you said?
Okay, it's just that I'm not writing, but
on the first one.
Yeah, but you would have understood better if I was writing. But for now, let me just explain. Okay, I'll repeat like you have told me. Yeah, on the first one here, I was saying the order is 2. Why? Because that's the highest number, I guess, that you can see in this equation. On this okay, we have the 2. Okay, let me just be giving examples on the y dx, the one that we are used to use them. So when we talk about dy dx, there's also the 2y dx2. There's also the 3y dx3. So when we look at those three differential coefficients I've mentioned, the highest order there is 3, because I mentioned dy dx, I mentioned the 2y d2x, I also mentioned the 3y d3x. The highest order there is 3. So if you've been told to find the order of such an equation consisting of dy dx, d2y d2x, and the 3y d3x, the order there is 3, because that's the highest number. And then the degree is simply the power of the power of the highest order of any given differential equation. So like when you look at this equation, I hope you are all able to see the pointer. When you look at this equation here, number 3, so on this equation, the highest order here is 2. So meaning we have d2y, d2, dx2. So meaning the order of this equation is simply 2. And then when you talk about the degree, for the degree, you don't get this 3, which is here. You simply get these 2 here, because that's the power of the highest order. The highest order we have is 2, and then the power of the highest order is 2. So here the order is 2, and then the degree is also 2. And then here the order is 2 because we have this d2y, d2x there. And then the degree here is 1 because the power of this d2y, dx2 is 1. So despite us having this power, which is 2 on dy dx, we've not gotten it as our degree. Why? Because dy dx is not the one which is having the highest order in this case. The one having the highest order is d2y dx2. On the first one here, when you look at it, you have the 2q dt squared, and you also have dq dt, and then so the highest order here is 2. So the highest order here is 2. And then the degree here is 1. So let's see here. So the order of the above equations is 2. So all these equations above here, the order is 2. Why? Because that's the highest number that we're having on these dy dx dt, dq dt. That's the highest order we have. Then when we talk about the degree of a differential equation is the degree of the highest derivative after removing the radical sign and the fraction. So when you get rid of the radical sign and the fraction, the answer that you get, the answer that you get, that's called the degree. And then always get the power of the differential equation, of the differential coefficient with the highest order. So the power of the differential equation, the power of the differential coefficient with the highest order is called the degree. So in this case, when you look at the above equations, the degree of equation 1 and 2 is 1. So when you look at the degree of equation 1 and equation 2 is simply just 1. Why? Because the power of d2q dt, dt2 is 1. The power of d2y dx2 is 1. That's the reason why we've said the order there is 1. And then the degree of the equation 3 is 2. The degree of this equation 3 is 2. Why? Because 2 is the power of d2y dx2. So if there was d3y dx3, we would have gotten the power of that to be our degree. I hope we are getting the concept. Don't worry, I'm recording. You have time to go through it.
How is life? How are you?
So let's look at now how you can form differential equations. So the first method that you can use to form differential equations is just by differentiating the given equation. Yeah, so when you've been given an ordinary equation, when you differentiate it, the answer that you get is called a differential equation. So after differentiating any equation, whatever that you get is called a differential equation. And then eliminating the arbitrary constants.
Who's there?
So we all know what an arbitrary constant is. It's just a constant when you have, let's say for instance, x squared plus 2. There the arbitrary constant is simply just 2.
Who is there?
When you have an equation,
Okay.
for instance, which is x plus 3, the arbitrary constant there will just be 3. So let's look at these examples there. So these examples, the question, I mean, this is example 1. The question says, for the following, for the differential equation, form the differential equation by eliminating arbitrary constants in the following cases, and also write down the order of the differential equations obtained. So when you look at this equation, this one you can simply get the differential equation of this first equation here by just differentiating it. You did differentiation in first year, and even last semester, semester 1 in engineering, you did differentiation. So by just differentiating this equation here, you can get what's this? You can get the differential equation of this equation. When you differentiate it and then you get rid of the arbitrary constants, what you get, or rather the result there, is called the differential equation. It's just that I can't write, but I had typed the the solutions. So let's look at the solution for the first part. Well, this is the equation here. This is our equation. This is our equation on the first question. So the first step that you do, you differentiate this. So when you differentiate that, when you find dy dx of this, you are going to get a as your answer. So now, this, when you look at a squared here, a squared is a constant. It's the one in this case we're quoting, and we're calling an arbitrary constant. A squared is a constant because it doesn't contain any variable. So ax plus a squared, when differentiated, we get dy dx there, and then we get our a here. So when you differentiate y with respect to x, you get dy dx. When you differentiate ax, you get a. When you differentiate a squared, you get a 0. So I've not just shown a 0 this side. So now, in this first equation, y is equal to ax plus a squared. Wherever there is a in this equation, you simply have to put now dy dx. So wherever there is a here, you put dy dx. Let's see what it's going to look like. So this is what we're going to have. Putting the value of a in 1, we get this. So meaning wherever there is a in this first equation, we'll put dy dx. So where there's a there, we put dy dx. This x you are seeing here, that is the x there. And then we have a squared, meaning where there's a, we put dy dx, and that's what we get. So this is our resulting differential equation. And then when you look at this differential equation, the degree is 2, because that's the power of dy dx. Then the order of this differential equation is simply just 1. Okay, so let's move on to the next question. Do we have any questions on this?
Wait, I have a question.
Okay.
When you differentiate the a squared, won't it be 2a?
No, we're differentiating this with respect to x and not with respect to a.
Just so it just
Oh.
Yes.
Okay.
You've understood?
Notice that you're not on.
Right. So we proceed.
Yes.
So the next question is y is equal to a cos x plus b sine x. So the first step is differentiating this given equation. So when you differentiate cos x, you simply get negative sine x. When you differentiate sine x there, you simply get cos x. And then this a and this b, these are just constants. So when you differentiate them, but they will not make any difference when you use product rule. They do not contain any variable, so you still get back to a. So what you just do here, you differentiate this cos x, you also differentiate sine x. So when you differentiate cos x and sine x there, you get this result. So when you differentiate y with respect to x, you get dy dx. So this will be equal to, when you differentiate cos x there, you simply get negative sine x. Like I said, this a will not change anything to just be there. And then this b will also come there. When you differentiate sine x, you simply get cos x. I'm sure you guys know about this. Yes. So we move on. So after differentiating this, you differentiate this again. You differentiate it. And after differentiating that, we're getting, when you differentiate dy dx, you simply get d2y dx2. I'm sure you agree with me on this one. When you differentiate dy dx, you get d2y dx2. Then when you differentiate negative sine x, you simply get negative cos x. Then when you differentiate cos x, you get negative sine x. So here now, what you're going to do is you factor out the negative. You factor out the negative, you factorize the negative, in other words. So when you factorize the negative, you're going to have something like this in the brackets. And it's important for you guys to at least get a book. If possible, just buy a new book where you're going to be writing all these that I'm explaining. Should also be solving on your own that side when I'm explaining, so that you know where you've understood or not, and where you've not understood. Yeah. So it's important to be solving along. And then starting from tomorrow and the other days to come, I'll also be solving here with my pen. It's just that the pen is not working. I tried it when I was starting, and you saw it gave issues, it failed. So I'll be solving as well. I don't like just explaining without solving. I always solve as well. So when we factorize here, we're going to have something like this. So this side you still have the 2y dx2, and then this side you have negative a cos x plus b sine x. Yeah, and don't worry, I'm going to send this slide to you. You'll be seeing this every day when you want to revise. So you are going to have negative outside and then a cos x plus b sine x. But when you look at this, a cos x plus b sine x, isn't it just the same as that? It is. So meaning while there is a cos x plus b sine x in this equation, we can simply just replace that by, with y. So while there is a cos x plus b sine x in this equation, we are simply just going to put y. And this is what we're going to have. So after having this, I think we are done. This is the differential equation. Yeah, because we've gotten rid of all the arbitrary constants. We don't have any arbitrary constant there. So the main purpose, or the many the many thing here you're supposed to be doing when making differential equations is just getting rid of the arbitrary constants. So now you just take this y to the other side of the equal sign, and you have your differential equation there with order 2 and then degree 1. The order of this differential equation is 2, and then the degree is 1. So let's quickly move on to the last question. The last question I wanted it to be solving because it's a little bit complicated. I wanted to be solving, but either way, I have no option. Let me just explain it. So just pay particular attention, because here we're going to involve product rule, and I guess product rule is not a problem with you guys. Yeah. So the first thing here, this side, you differentiate y squared. How do you differentiate y squared? So here, y squared, when you look at it, when you differentiate y squared, we're going to use what is called implicit differentiation. You don't just differentiate it anyhow. Same applies to this other part. This other part is also implicit, but it's because we're used to x. That's the reason why you just see it to be normal. So this is when you differentiate ax squared, you simply get 2ax, Then when you differentiate bx, you get b. When you differentiate c, that's a 0. But when you differentiate this other part, you simply differentiate it the normal way, meaning you're going to have 2y, and then you also have to include dy dx this side. So what I'm trying to talk about is this. This side, when you differentiate y squared, you differentiate y, you drop down the 2, you subtract the 1 from the 2, you get 2y. And then you also have to include dy dx. This is called implicit differentiation. So it's just that I'm not writing. I would have shown you how this is coming about. But on this other part, I'm pretty sure you know what is happening. Differentiate ax squared is going to be 2ax. When you differentiate bx, you get b. When you differentiate c, you get a 0 this side. So let's continue. So after differentiating this, we're trying to get rid of all the arbitrary constants in this equation. So we simply differentiate it again. So when you differentiate this part here, the first part this side, on the left-hand side of the equal sign, you discover to say we have two functions here. We have dy dx, and then we have 2y. So what you do when differentiating such, you simply use what is called product rule. So you use product rule. How do you use product rule? You first hold this 2y and then differentiate dy dx. So when you put 2y there, you differentiate dy dx, you are going to get 2y times the 2y d2x, dx2. So this is what has happened on the first part here. And then you write a plus. We all know the formula for product rule. I would have written it somewhere, but the marker is not working today. Yeah, but I'll fix it tomorrow. Starting from tomorrow, going on these other days, I'll be writing. So you write 2y and then you differentiate dy dx, you get that, and then you say plus. You differentiate 2y, you write your 2 there. When you differentiate 2y, you get 2 dy dx. When you differentiate 2y, you get 2 dy dx, multiply by dy dx, meaning the dy dx will be 2. So dy dx will be raised to the power 2. So what I'm trying to say is that when you differentiate 2y, you get 2 dy dx, and then multiply it with this dy dx, you get dy dx raised to power 2, and then times 2. So this is how this came about. And then when you differentiate this other part, when you differentiate b, you get a 0. When you differentiate 2ax, you get 2a. So this equation is not done. We still have this 2 there. How do we get rid of this? We still have this a there. It's an arbitrary constant. So how do we get rid of this? We still have to differentiate again. So we differentiate this again using product rule. So when you differentiate this, you are going to differentiate, you are going to say 2y times the times the derivative of the 2y dx2. So this 2y times when you differentiate the 2y dx2, you get the 3y dx3. So when you get the 3y dx3, you multiply it with 2y. And then you say plus the 2y. Let me just show you what I'm trying to talk about. It's here. So when you get this is what I talked about, the first part there, and then you say plus. You differentiate 2y. You differentiate, yes, 2y. You get 2 dy dx, and then multiply it by the 2y dx2. This is what they've done here. Yes, but I'm sure you are all surprised why you can't see a 2 in front there. But don't worry, I'll show you where it went. And then you have this 2 there, which is outside there. And then you differentiate this by chains rule, because this is a function in a function. This is a composite function, so you use chains rule. So you differentiate this by chains rule. You say 2 times 2 there, you get a 4 here, though you are seeing a 2. Okay. No, you are seeing a 2 in front there. So you say 2 times 2 there, you get a 4. It's supposed to be a 4, but I'll show you the reason why it's a 2 there. And then you say this dy dx to the power 2 minus 1 there, it will just remain dy dx. And then differentiate what is inside there. Differentiate dy dx, you get d2y dx2. That's what you have outside there. And then when you differentiate 2a this side on the right hand side of the equal sign, you just get a 0. So you can try to solve it out on a separate paper there. You see how this is coming about. Yeah, so let's see where we're going. So we have finished writing this. And then when you simplify this, I'm sure you can see that you can add these two. Oh, I told you to say I'm going to show you why this is 2 instead of 4, and why we don't have a 2 there, and why we don't have a 2 there. It's because we divided everything by 2. We are supposed to have a 2 in front there because this is 2y. You are also supposed to have a 2 in front there. You are also supposed to have a 4 there. So we divided the whole equation by 2 to get to this. So after getting this, you can see that this part and this part, they are just the same. You can add them, and then you get 3 dy dx d2y dx2. So this is our differential equation that we needed. So having found this, we can now determine our order and our degree. So the order here is 3 because this is the highest order is 3. The order is 3, and then the degree is 1. The power of this differential coefficient with the highest order is 1. That's the reason why we've said the degree is 1. So let's quickly move on. Yeah, so this is what I was talking about. The order is 3, and then we have obtained it by eliminating the 3 arbitrary constants, which are a, b, and c. Okay, so I think this is where we're going to end today. Yeah, this is where we're going to end today. I don't know if you guys have any questions. I just wanted to introduce differential equations. The next time we meet for mathematics, we'll enter into solving serious questions on differential equations. This is just an introduction. We have not even started solving. So do you guys have any questions? All right. So silence means that we've all understood. And don't worry if there's any part where you're behind. I'm going to send the link to this video. You can watch it on your spare time or on your time. But there's an exercise at the end. So you are supposed to solve this exercise. So you can see the first question is telling you to write the order and the degree of the differential equations, which are these. So here, just make sure that you simplify the equation before you take the degree. For instance, on this part here, the question says, I mean, the definition of a degree of any given differential equations is you get the power or the degree of the highest order after eliminating the radicals. Here in this second equation, you can see that there is a radical there. So after eliminating the radical, you see and you get the order. You get the degree. Yeah, so you are going to work out these questions, and then I expect to have the solutions before Saturday so that we can have our next lesson. I need to see how you have understood what I've taught today. Then if I see that you've understood, that's when we can proceed. Then if there is anything that I will need to control you, or if there's any mistake you're going to make, I'll control you through WhatsApp, and then I'll explain where you went wrong. And then you can see here the second question is saying, obtain the differential equations of which y squared is equal to this, equal to 4a x plus a is a solution. So in other words, they are trying to tell you to say, find the differential equation for this question there. Same applies to the third question here. They are also asking you to find the differential equation. So thank you very much for watching today's, for attending today's lesson. I'll see you in the next lesson, preferably on Saturday, if I'm going to have time. So tomorrow we might have dynamics. Yeah, we might have dynamics tomorrow. But for today, I think we end here. If you have any questions, you can ask. If you have any concerns, you can ask. All right. So this is a sign that you have all understood. So see you in the next lesson. I'm going to send this slide and I'll also send the link to this video. See you on Saturday. Shalom, shalom.